This video will help you understand the structure of atoms. What are atoms? Let's take a closer look at atoms. Have you ever noticed what is the building block of a huge building? Yes, you're right, a brick. Then what would be the building block of an anthill? Yes, it is a small grain of sand which makes an anthill. Similarly, all states of matter are made up of atoms. In our previous classes, we have already studied about the three states of matter: solid, liquid, and gas. Now, if we take these three states of matter and zoom it many times, so much so that we are able to look at the individual particles that make up these states of matter, we will be able to understand that atoms are the building blocks that make up everything. That means they make up all these states of matter. Atoms are so small that it is hard to imagine. Now imagine how thin this sheet of paper would be. But on close observation, you will find that more than millions of atoms, when stocked together, would make a layer barely as thin as a sheet of paper. Now, can you understand how small atoms are? Now, we'll take an even closer magnified look of one atom, and we find that atom is made up of even smaller subparticles. That means, like everything is made up of tiny building blocks, atom is made up of even smaller building blocks. At the center of the atom, we have nucleus. This nucleus is made up of two subparticles, protons and neutrons. At the outside of the atom, in the shell or orbit, we have electrons, which constantly move around the nucleus at a very high speed. The proton, which are present in the nucleus of an atom, are positively charged. That means they carry a positive charge. The neutron, as the name says, they are neutral. That means they carry no charge. The electrons, on the other hand, have a negative charge. So each electron is carrying one negative charge. Understand this with an example of carbon. Carbon has 6 protons, 6 neutrons, and the number of electrons is also 6. Now, as I told you that electrons are revolving around the nucleus at a very high speed. So the question is, why do they not fly away in the space? What makes them bind to the atoms? The reason is that the negatively charged electrons are attracted to the positively charged protons. This holds the electrons from flying away from the proton. Another question which could come in your mind is that why not the electrons get attracted to the protons? Because electrons are negatively charged, protons are positively charged. So why don't they crash into the nucleus? The answer is the electrons are moving at an incredibly high speed. They're very fast. That's why they do not pull towards the protons. Now, sometimes people think about the role of neutrons, which carry no charge. Well, the main function of neutron is to attract each other and keep the nucleus of an atom intact. They attract each other by the strong nuclear force. However, protons repel each other with the electromagnetic force since they have a like charge. Now we'll be studying about atomic number. The number of protons determines the identity of an atom. The number of protons is always equal to the number of electrons in an uncharged atom, as the positive charge carried by protons is equal to the negative charge carried by the electron, and this is known as its atomic number, which is represented by the letter Z. That means Z is equal to P, that is protons, which is equal to E, which is electron. Another thing which is very important in an atom is atomic mass, that is how much mass it has. To understand this, we have to understand the mass of its subatomic particles. Protons and neutrons are similar in size and mass. They both weigh around 0.0000000000000000000000167 grams. Can you imagine how small one proton is? We can write this huge number as 1.67 into 10 to the power minus 24 grams. But this itself is again a difficult number to remember. So scientists denote this number by writing it as 1 AMU, that is 1 atomic mass unit. So that means one proton or one neutron weighs around 1 AMU. An electron, on the other hand, is much smaller than proton or neutron. Mass of one electron is equal to 0.000549 AMU. That is a tiny fraction of how much the weight of proton and neutron is. That is why we do not count this negligible weight in the weight of atom, because they are so tiny that they do not influence the weight of atom. Hence, atomic mass, which is denoted by the letter A, is equal to mass of proton plus mass of neutron.